Today we're going to be looking at classifying matter based on its composition. Keep in mind that matter is anything that has a mass and a volume. So that's really all of the samples of materials that we're looking at. The things that would not be included in matter are things like energy or forces. If you have a sample, then your sample is matter. And really to determine what type of matter you have to look at its composition or what it's made of. If it has a definite composition, that means that every sample will be identical in terms of what elements it's composed of and the ratio that those elements are found. As long as you have a definite composition, then you're looking at a pure substance. Pure substances are created from only one type of representative particle per sample. So that could be a single type of atom, which is the smallest part of an element, or it could be one type of molecule, which is actually a combination of atoms that are chemically bonded, and that molecule, that group of atoms, is repeated over and over in the sample in order to create a compound. If different samples of your matter could have varied composition, which means maybe they have different elements from sample to sample, or more likely, different ratios of those elements, then you have a mixture. And mixtures are physical combinations of pure substances, which means they contain either more than one compound, more than one element that's not bonded together, or sometimes even mixtures of elements and compounds that are not bonded together to create new molecules. That's why we say they have more than one type of representative particle. If you have a mixture, you can further classify it as a homogeneous or homogenized mixture, or a heterogeneous mixture. Homogenized or homogeneous just means that there's an even distribution of your representative particles, so they look like they're within a pattern. Whereas a heterogeneous mixture would have different regions within your sample that are more heavily one of the representative particles rather than the other. Think about that in terms of either layers or maybe just areas within the sample that look a lot different. So if we're looking at our 4 different types of matter, we can start thinking in terms of how to very easily classify these things. The first way we would do that is actually the most cut and dry way. It's pretty obvious which of the 4 we have based on our models. And these are atomic sized models. So the models that we create use different shapes for different atoms that then represent different elements. And if our entire sample is only made up of one type of atom or one type of element, it's pretty easy because we just use one shape. So here I'm going to use triangles, but you could use squares, circles, whatever shape you wanted, as long as you just kind of copy and paste. You're repeating the same shape over and over again. If you only have one type of atom, that's one type of shape, or even one type of shape with a certain color, now you have an element. If instead we're trying to represent a compound is going to have more than one type of atom, but they're going to be bonded together in the same way over and over again. So this time maybe I'll use circles, but I'll use different colors of circles. So here I have 2 white circles bonded to a purple circle. And if I take that same grouping and copy and paste it, or just redraw it over and over again, you'll see I have the same type of molecule, which each molecule is composed of 3 atoms. But since it's only one type of molecule or one type of grouping, that's still a pure substance, but now it's a compound. If I combine these, then I could get a homogenized mixture as long as I have an even distribution of the 2. So think of it in terms of like a pattern. And it might not be a perfect pattern. Maybe the spacing is a bit off. But there's a definite attempt to make it look like these things are evenly distributed. That would be a homogenized mixture, whereas a heterogeneous mixture is going to be different areas that have a higher concentration of one of the types of representative particles than the other. So that would be something like this. Now it's pretty easy to determine which type of matter we have based on these diagrams, but unfortunately we don't live in a world where we can see these submicroscopic particles. So instead we have to look at clues based on our macroscopic scale, the things that we can see, in order to really categorize which type it has. So the first thing that we'll look at are our elements. And really, elements, you're going to have to use some prior knowledge and a pretty powerful tool that you have. Elements are things that are on the periodic table. So if you are told the identity of your sample, you can look on the periodic table and say, is that thing on the periodic table? If so, then it's an element. So that would be like oxygen. Oxygen is on the periodic table. Oxygen is an element. Or even carbon. Carbon is on the periodic table, so carbon is an element. Elements are also represented by a single symbol. And remember, the symbols are just the abbreviations on the periodic table. It's one or two letters. The first letter is always capitalized. The second letter, if there is one, is always lowercase. And it's really just an abbreviation of the element's name. Some of them are a little weird. Things like lead is PB, and that's just because those symbols are so old. They're based on older names of the element, like lead used to be called plumbus, so that's why it's PB. Don't let that stuff throw you off, though, because you always have your periodic table that has all the symbols and the names listed for you. You just have to be able to locate them fairly quickly. Compounds, on the other hand, are going to be chemical combinations of elements, which means you might be able to find the pieces of the names on the periodic table, but there's more than one of them smushed together. This would be things like carbon dioxide or sodium chloride. You're going to notice a lot of them have a very common IDE ending. So if you see something that ends in IDE, you can be pretty sure that that is a compound. And another clue you can look for is that it's represented by a formula. For instance, H2O. We have the H and the O, which were different elements, and then we have that little 2, which tells us the number of hydrogen per each oxygen. So formulas give us the elements and the ratios that they're found. And formulas are going to be a representation of that representative particle of the molecule. Homogenized mixtures and heterogeneous mixtures are, like we said, physical combinations of these things. So when you're looking at those to determine whether or not it's a mixture, first of all, and then when you know it's a mixture, whether it's homogenized or heterogeneous, you're really going to be looking at what the description tells us. Heterogeneous is the easiest thing out of all of these to classify, because on a macroscopic scale, the heterogeneous mixture is the only one that you can easily look at a sample and just see that there's more than one layer or more than one part of the sample. You can see some chunks that look different than other parts. So heterogeneous mixture is the one that looks like there's more than one thing within it. So think of like a salad or a bowl of soup, or even an aquarium where you can see the water and you can see the gravel in the bottom. If you can see more than one thing within your sample, then it's going to be a heterogeneous mixture. Homogeneous mixture is a little bit trickier because it actually looks pure even though it's not. This would be things like salt water or Gatorade, or really even iced tea. Anything that would be considered a solution. And for this, you're going to have to look at the name and use your prior knowledge. If you have a sample of matter that looks like one thing, but when you look at its identity, it's obvious that it contains more than one compound, or it contains different proportions of elements and compounds, even if it looks like one thing, it's got to be a mixture. And that means it's a homogenized mixture or a solution. So this would be things like salt water, Gatorade, anything that you know based on maybe a nutritional label that it contains more than one compound, but it still looks like it's one thing. So again, your goal is to be able to look at submicroscopic diagrams, things like we have here in the purple, and easily classify to say, oh, it's got one type of atom, therefore it's an element, or it has one type of molecule, so it's a compound. Or there's a pattern of representative particles, homogenized mixture or homogeneous. And then the one that doesn't have a pattern, the uneven distribution, that would be heterogeneous. But your goal is also to be able to look at identities or descriptions of samples and be able to classify them based on these red topics. Let me know if you have any questions or concerns as you're going through the practice problems and or the lesson review questions. And definitely communicate, communicate, communicate.